Right, okay. Now, the beauty about these kind of questions, you're going to get marks for setting things up, okay, which is standard. Just read the question carefully. The level of grams per milliliter in pollutant different locations of a certain river denoted by random variable x, and that has that distribution. Okay, so x has this normal distribution of mu 0.1234 divided by 409. Okay. In the past, that's mu, so you can get rid of that and call it 0.0340. Oh, so okay, so that's what it's been in the past. Done that. Now it goes here. This year, the mean level of pollutant at 50 random chosen locations is this. Then it goes here, use this per milliliter. Test at 5% significance level whether the mean, now this is a key thing, mean level of pollutant has changed. Okay, that's the crucial word here, is changed. Okay, so now we kind of set it up. So first of all, you write your null hypothesis, and we're calling mu, and you got to call the mu what it is. It's going to be 0.0340. Now you could get a mark for that, and you get a mark for this alternative hypothesis. You say has changed means it's no longer equal to. Don't put greater than or less than. Okay, we'll look at that later, but at this moment in time we just put has changed. That means does not equal that. Have we got enough evidence to say, to make a claim it's not that, which means it's changed? Okay, then the other thing is to remember that they took a random chosen 50 locations. Okay, so instead of the whole population where that came from, all these rivers, they took a sample of that. So this is going to be a sample. So now going back to that, you can then say that x has this normal distribution. This mean does not change, normal distribution, so the mean stays as 0.0340, that's mu. However, it is 5 zeros yet. 0.1234409. Now don't forget again, this is the variance. Okay, so when you put it in the calculator, you must square root it. I'm going to share that over 50, because then you can do it all in one go. Divide it in the calculator, does it quite easily. So that's what that distribution follows. Also, you got to say that significance level. Now if you are testing between two regions, I'm just going to draw the normal distribution here. Now when you say it's not changed, we're going to test it for, it can be less than or greater than that value. Okay, so we were testing at 5%. This time we must share that 5% between these 2 points. So this time significance level is going to be 5% divided by 2, so 0.025. So we're going to test it for that. And if you want, it's always a nice thing to say this is a two-tailed test. Okay, so far you've got at least 3 marks. Okay, you might even get 4 marks, 3 marks straight away. You said that 1, 2, actually 4 marks, because you said that's divided by that, and you've also stated the significance. So I reckon a good 4 marks we've got, and this is standard. Okay, now obviously if it was just one-tailed, you don't half it and you just claim that is there, and that only happens if it's greater or less than. If they said the mean had increased, there was more pollution, or there was less pollution, then if there's more pollution, mu would have been greater than, less pollution, mu would have been less than. Okay, so okay, now let's set this up. So we know in the past that has been that. Now from our rivers, they found, from the 50, they found that to be the case. So we need to know, now first of all, you need to know whether it's greater than or less than. So we need to make a choice. Is that smaller than that? They could have made that bigger number, but in this case that is smaller than that. Can you see that? So we need to set it up and say what was the probability of this mean that they found, the mean that they found, okay, is less than 0.3, sorry, 0.0325. So don't mix it. Loads of kids mix this up. That stays as it is. We want to know what was our chances of finding something that was that or less than. We don't put less than or equal to. In normal distribution it's continuous, we just say it's less than, it includes that. Okay, now can you just put that in your calculator, please? Just go into your calculator, put these conditions in. So I want you to put in mean is 0.0340, and now be careful here. Can you put square root of all this in brackets, please? So square root, put this fraction in. I'll listen to the fastest person to tell me what they got in the calculator. Go on then. I've seen you stop pressing buttons. So what did you get?
0.048.
Excellent. 0.048. I'm just going to do it to 3 single figures. 0.0486.
Which one do you put it in? Normal something? Yeah, do your lowest number.
Yeah. So your lower bound, you put it as negative 999. Yeah. And your upper bound is going to be that. Square root of that. Just be careful with zeros. You okay with that? Good. Okay, can you just put minus, just put, whenever you do minus, just go like that. There it is. Got it. Now, just put, because you're going on that end, you understand me, yeah? When you're using your upper band, you put 999 or whatever, just put a massive number. Your lower band, just put negative number. It is continuous, it goes on. Just choose a ridiculous massive number to go by. Right, so you get that. Now, once we've got that, that's our 5th mark. What can we say about this? We can say that this is greater than our testing region. Now, this is the critical region. Anything less than that, we reject the null hypothesis. But this is greater than that. Therefore, cannot, you must explicitly write this down, cannot reject the null hypothesis. Right, we cannot reject the null hypothesis because the chances of getting that was well within our region of testing. Okay, so we cannot reject the null hypothesis. And now you got to get stats. So you got that 5, you got that 6 by saying that. The last mark, you got to write a little statement. You can just say there is not sufficient evidence to suggest mean level of pollutant has changed. Full stop.